Cool. Awesome. Great to meet y'all. I'm Kevin. I'm one of the founders at Unspun. You could jump to the next slide. See, just this play. Here we go. Cool. So quick concept demo. We're very focused on textile manufacturing, and even specifically the 3D scan to fit side. So we'll talk more about this in a second, but our core tech revolves around both an additive manufacturing process, as well as this like mass customization angle from the 3D scan component. Cool, you can jump to the next slide. Quick bullet points, here's your notes if you need to write anything down. Our main point is textile manufacturing doesn't exist in the US. It will soon. We think the secret's fully vertical, automated, and additive. We'll talk more about what those mean. Fundamentally, the next closest thing to us, we're 5 times faster and about 10 times cheaper. And we can show why that makes sense. Then finally, just on the commercialization side and partnerships, we've taken a very focused approach in commercializing as we develop. So we didn't just build a tech and are trying to see if it works, but we've actually have a consumer-facing side of the company as well. So next slide, please. So kind of fundamental problem on this. Our big point is textile manufacturing will come back to the US. It fundamentally requires automation though. If it were to come back to the US via human labor, probably would have happened in the last few hundred years. Lots of tailwinds on this. There's geopolitical, there's automation, there's nearshoring, there's ports backed up. So fundamentally, we're trying to think about when one of the biggest industries in the world, a $1.5, $2 trillion industry returns to the US, what does that look like? So you can jump to the next one. At Unspun, maybe there's an next one. Yeah, Unspun, our mission is very climate focused, but also particularly looking at the overlap of profitability and sustainability. So we're thinking about where can we be creating gigaton scale carbon emissions reductions while also creating fundamentally just a more profitable manufacturing method, specifically focused on textiles. So in the next slide here, I can show you a little bit on, okay, what is the automation stack of textiles right now? Where do things work? Where do things break down? Fundamentally, you have this great discontinuity at the human sitting at a sewing machine. Very easy for very basic, low-skilled labor to do. Very difficult from an automation robotics perspective. Car chassis is easy to swing around and model and know where everything is. Soft fabric rolling over itself on the sewing table is surprisingly difficult. So there's a few different groups kind of really honing in on this like cut to sew step. This is where the automation chain has fundamentally broken. A lot of these others have great automation tech in there. But this is kind of the big blocker. And if you jump to the next one, we can show our solution. We actually were really quiet about this component until just 3 to 4 weeks ago, which we announced in Time Magazine. Vega is our new manufacturing process. It's seamless. We can use conductive materials and fundamentally it's additive. So there's a lot of different things we can do by building in 3D rather than just flat fabric. So wrapped around that, we've been thinking about that first commercialization spot. Our Tesla Roadster is bespoke, really leaning in on the on-demand component that's necessary and custom fit and working backwards from there. So if you jump to the next slide, I can't show you full video of our machine, though I can if you want to chat more later and we get some paperwork in place. Ooh, if you can mute this one, it might be really loud. This is a good catch. This is a 3D knitting machine, kind of next best process in additive or automated apparel manufacturing. Really great in that you can do effectively like near net final shape garments. Downside is that it's slow and it's expensive, about 2 hours to do a garment and the machine's about $1 million. It only does knits. Knits and wovens are kind of 2 main categories. Not totally worth going through here. Our fundamental tech is wovens only. Big difference is we get that throughput from 2 hours to 9 minutes. That's at today's scale. That's not a theoretical. And CapEx is our machines are about $60,000. So if you jump to the next one, fundamentally, I think I even saw something pop up in the chat. Why does additive make sense? Fundamentally, there needs to be an additive step anyways of turning yarns into fabric. We're saying rather than just do that in flat fabric, you should just do that in 3D. So skip the need to go flat fabric, do the cookie cutter, cut and sew step to get to 3D, but just go directly from yarn to a 3D final product. Here in the next slide, just click on the consumer facing side. So we developed this core tech for automated additive 3D weaving. We've actually built a consumer-facing brand around this concept as well. If you look at unspun.io, which is our website, you'll see that we're actually a custom denim brand. We do this all based on depth data captured from iPhones. We can make a 3D model of a customer and then perfectly build the garment around them. So they're on the far right, you're looking at top are real photos, bottom is our automated rendering side. We are focused on the consumer side on custom denim. So we convinced the head of design at Levi's to leave and join us because he was really inspired by this process. Here on the next slide, we're kind of showing some of our first 3D woven outputs. So this is all built in this. This is all built on this additive seamless process. These are garments that came directly out of the machine. And then quick warping through these last few slides. Fundamentally, we're thinking about, there we go. We're thinking about, this core technology needs to win on that raw automation scale. So speed, reliability, cost is going to be the big ones. We believe that this tech, we can make products cheaper in the US on demand than you can make ahead of time in Bangladesh, Sri Lanka, what have you. We're on our way there, not there today, but we think we're fairly close. Next slide, we can probably skip through a bit. There's a strong data component from the 3D scan. We're starting in the consumer side with fashion. We think it's strategic and like proving that this process can work. If you can make $200 garments, you can very easily make $1 million 3D carbon fiber parts and whatnot. Next slide on the additive angle, it's already happening. Shimaseki in this 3D knit world is big in Japan. They're already building these additive microfactories, and then if we kind of just jump maybe two more, I don't know, quick kind of overview on why does 3D weaving make sense. Maybe back one. It's seamless. There's a lot of different things that you can do. So by building a garment, knowing where you are, we can do things like make the knees thicker or put conductive heating elements all the way through the garment for our military customers. Or even a big one that we're seeing lately is like seam tolerant stack up. So lots of different reasons why we think going straight from yarn to that 3D makes sense. And then finally, just on this last slide, we are a venture-backed company. Maybe one more. We are a venture-backed company. Oh, sorry, maybe one back. I didn't realize there's one in between. We're a venture-backed company. Also have done quite a bit through SBIR already. We've done a fairly strong lap through the NSF side of things, are currently working with AFOA, DevCom, and are also in the process of seeking out other federal partners as we go through this process. Some other applications beyond just the proving core tech on the consumer side with custom denim, other things we've been exploring is the ballistics protection, a lot of the optical or conductive elements. We talked about reducing bulk and lots of those like localized performance optimization. So be that for pressurization or anything along those lines. And then we're based in downtown San Francisco, 3 founders plus an incredible team of engineers. My background is in robotics, surgical, a little bit of aerospace. My co-founders, Beth and Walden, both come from the apparel side, one on the technical design and another in being on the supply chain, industry forecasting range of things. So yeah, I saw a few questions pop up in the chat. We could start with a live one and then I'll try and get caught up on that.
Now let's start with the panel for a second. That's a fantastic technology from Unspun. Questions from the panelists.
Maybe just basic question of kind of price in terms of price comparison, competitiveness of price to this kind of standard industry.
Yeah, so within kind of, I guess, two key comparisons. One, within the existing additive manufacturing approach, we kind of talked about that benchmark of about 5 times faster and 10 times cheaper. Within general apparel, we are working towards hitting cost competitiveness. So the bar for us and what we're working towards is this should be net cheaper than producing via human labor in choose your third world country. We haven't hit that price point switch over yet, but all indications are that we're well on track to do that.
Well, when do you estimate you'll do that?
With about 20 machines, because the throughput on this process is so high. And again, this is for benchmarking just at like bottom of the barrel apparel. So if we go to $1 million, carbon fiber parts, that's a very different game. But even just like type of apparel you would get at like Walmart, for example, with 20 machines in a single facility, we can do almost 1% of US denim. So we're really optimized for high throughput. So we believe that basically by the time that we get to our second factory installation, which is one more funding round from now with 20 machines, we can be proving cost competitiveness, producing products onshore at the $40 to $50 price point, which when you factor in everything else in the scale within apparel puts us at a cost competitive manufacturing process.
Go ahead.
Maybe I
couple of
just make a
questions.
recommendation for the panelists to push the raise your hand button, and then we'll be able to queue up. But Mark, go ahead.
Yeah, so maybe I missed it, just a clarification. You're focusing on large scale manufacturing, or you're focusing on the custom market? I know you mentioned both, but what's kind of your initial focus? You want to manufacture for big brands, or you want to manufacture for like bespoke custom online suit companies?
Yeah, great question. We think about the technology progression here as a matter of getting to scale, very much following the Tesla approach. So our first product is an expensive Roadster. You don't sell a lot of those. You keep using that to work more towards that Model 3. So for us, the Roadster is the bespoke product. It's more on the luxury side. We can do small batches of multi-$1,000 products, but ultimately we're working towards mass manufacturing.
A question on your IP position, and also for your 3D knitting, is it agnostic to the type of yarn, and how is the kind of fiber density compared to conventional textile manufacturing?
Yep. We have 2 patents granted. We have 3 more filed. We spent quite a bit of time working with one of the leading patent strategy firms to map out the white space of this world and make sure that we're patenting the important choke points. We've done quite a bit in hardware. We've done some on the software process, and we've actually done some on the actual seamless 3D woven outputs. So fairly aggressive IP approach in that sense. And then the other question was on material compatibility. For the 3D weaving process, we're material agnostic. So there's a general range of elongation and ultimate strength that we need to tune to. So kind of just more of a question of modifying machines to fit. But so far we haven't found a material that we cannot use.
And how is the fiber density and performance of it compared to conventional textiles?
It's still fundamentally weaving. So there isn't, the difference is that we're doing it seamless and in 3D. So in the exact same way that you could get performance of a conventional woven garment, be that or either garment or carbon fiber element, we can do the same thing, but we just eliminate the need for seams or for layering.
Go ahead, Don.
Interesting. Thank you.
Don, you can go.
How much money did the company raise to date?
Yeah, so we closed a $8 million seed round for 2021 of us this past August. We had done about, I think about 3 in venture prior to that, and have about 2 million in grant funding. So, it was about 2 before in grant funding and 1 in, 2 in pre-seed, 1 in the grant funding side. So in total, about 10 million.
Thank you.
And then I see 2 questions from Josh in the chat. How is additive cheaper than high volume negative manufacturing from one piece of cloth with one size? Big component is that there is still an additive step. So you still need to go yarns to flat fabric, then you transport it to a different facility. And you go from flat fabric to cut piece. We just go direct and skip steps. So a big component of why this is cheaper is that we're reducing a lot of complexity in the steps in the process. And then privacy concerns with 3D scans. There's always a bit in any sort of new tech. We see a lot of great adoption. We already have some of the biggest brands in the world paying us for this. In fact, even the privacy element has become a competitive advantage for us. A group like H&M doesn't want to own that type of data, and they're happy to let us own it and happy to pay us every time they have a question about their customers, general morphology. So for us, that's become a really, really tactical part of the software side of our business. And yes, you do need to wear tight-fitting clothes while scanning. So like yoga pants, tight-fitting underwear, anything like that. It just uses whatever that depth sensor can pick up. And then we also have these physical in-store units as well.